Hi, in today's video I would like to introduce you a very nice problem of Turkish Mathematical Olympiad edition 1999, question number 6. Here is a following statement. There is two sequences. We have the first sequence x1, x2 up to xn, and we have the second sequence from y1 up to yn, okay, are defined in the following way, okay. We have x sub 1 equal to y sub 1 equal to square root of 3. We have x sub n plus 1 equal to x sub n plus square root of 1 plus xn, x sub n quantity square. We have y sub n plus 1 equal to y sub n over 1 plus square root of 1 plus y sub n quantity square. So the question prove the product x sub n and y sub n is strictly superior than 2 and is strictly inferior than 3, okay, for all n strictly superior than 1, okay. If you heard about the Fibonacci sequence or recursion sequence, are almost the same, just Fibonacci has the sum, the recursion has the product, okay. Anyway, we have this product x sub n and y sub n is squeezed into two numbers, 2 and 3, so that's our goal. Go ahead, pause this video if you would like to give the try to this problem. Anyway, come back to see the full solution. Okay, let's get started now. The first thing I'm going to do, let Zn as a new sequence equal to a reciprocal of y sub n, okay? So I'm going to determine Zn by replacing 1 over y sub n into this equation system. So now this implies y sub n plus 1 equal to 1 over z sub n plus 1 equal to 1 over z sub n over 1 plus square root of 1 plus quantity square. I'm going to simplify this one. So this one, by simplifying this one is giving me 1 plus zn square plus 1 square. I'm going to take zn square outside of this square root. We will have z sub n, and multiply zn by 1 is giving me zn. The whole thing is divided by zn. By taking the reciprocal of this one, so implies I will have z sub n plus 1 equal to zn plus square root zn square plus 1, okay. After simplifying this one, we will find this one. Now I'm going to calculate z2 by replacing 1 over y2. I'm going to find y2 by replacing n by number 1. So I will have y1 equal to y2 equal to y1 over 1 plus square root of 1 plus y1 square. So y1 equal to y sub 1 equal to square root of 3 as the initial condition, which is square root of 3 over 1 plus square root 1 over 1 plus square root of y sub 1 square, which is 3. 1 plus 3 equal to 4. Square root of 4 is 2. 1 plus 2 is 3. I will have square root of 3 over 3. By taking the reciprocal of this one to find z2, so I have z2 equal 1 over y2, which is 3 over square root of 3, which is square root of 3. If you take a look at this value, I have this z2 equal to square root of 3, which exactly equal to x sub 1, okay. This one implies xe as zn plus 1, and as you see z sub n plus 1 and x sub n plus 1 are written on the same form, and also we have the same value, and also they have the same first term, which is z2 equal to x1, implies this sequence x sub I and z sub I are satisfied the same recursion. This implies x sub n minus 1 equal to z sub n, okay? Because we found z2 equal to x1 and are they written on the same form of the as a recursion sequence, okay? And moreover, we have this sequence x sub n plus 1 equal to x sub n plus square root of 1 plus x sub n squared equivalent. I'm going to bring x sub n to the other side. I will have x sub n plus 1 minus x sub n equal to square root of 1 plus x sub n squared, which is strictly superior than 0. This implies x sub n is increasing sequence. Okay? And also we have y sub n equal to 1 over z sub n. I'm going to multiply by both sides by x sub n. X sub n is multiplied by y sub n equal to x sub n over z sub n. What I'm doing this one because I'm going to prove this one. That's why I have to write it on this form. So in the same time, x sub n over z sub n we found equal to x sub n minus 1. Okay? Now I'm going to work out on this one in order to find the relationship between this quotient and number 2 and 3. Okay? If you take a look at here, we have this equation. I'm going to put it on this form as well. X sub n equal to x sub n minus 1 plus square root of 1 plus x sub n minus 1 quinary square. Okay? And on the other hand, we have 3 x sub n minus 1 quinary square is strictly superior than 3x sub 1 square, because as we have increasing sequence, so that's mean x sub n minus 1 is strictly superior than x1. So this one is strictly superior than this one. In the same time, this one is strictly superior than 1. Okay? Now I'm going to add x sub n minus 1 square on both sides. I will have 4 x sub n minus 1 square is strictly superior than 1 plus x sub n minus 1 square. I'm going to square both sides. So we'll have, if I'm going to square this one, I will have 2x sub n minus 1 strictly superior than square root of 1 plus x sub n minus 1 square. Okay? And also, I'm going to add one more x sub n minus 1 on both sides. So I will have 3x, I will have x sub n minus 1 plus 2x sub n minus 1, which is equal to 3x sub n minus 1 is strictly superior than x sub n minus 1 plus square root of 1 plus x sub n minus 1 square. This one equal to this one, as you see it here, equal to x sub n. Now I found the relationship between x sub n minus 1 and x sub n. Okay? This one equivalent x sub n is strictly inferior than 3x sub n minus 1. I'm going to divide both sides by x sub n minus 1. So we'll have x sub n over x sub n minus 1 is strictly inferior than 3. This value, we already prove it. We have this value, we already prove it. We have x sub n over x n minus 1 equal to x sub n is multiplied by y sub n. Okay, I'm going to replace it, this one. Now we have proven the right hand side of this inequality. I'm moving on to the left hand side of this inequality after cleaning up this board. Okay, in the last board I was working on this inequality, and came up with this result. Now I'll continue working on the left hand side of this inequality. Okay, as you have here, so we have x sub n equal to x sub n minus 1 plus square root of 1 plus x sub n minus 1 quantity square. Okay, I have reduced this equation to this equation. Okay, so now, as we know, 1 is strictly superior than 0. I'm going to add x sub n minus 1 quantity square on both sides. So we have 1 plus x sub n minus 1 quantity square is strictly superior than x sub n minus 1 quantity square. Okay, I'm going to square both sides. I will have square root of 1 plus x sub n minus 1 square strictly superior than x sub n minus 1. Okay, I'm going to add one more x sub n minus 1 on both sides. So I will have x sub n minus 1 plus square root of 1 plus x sub n minus 1 square is strictly superior than x sub n minus 1 plus x sub n minus 1 equal to 2 times x sub n minus 1. Okay, so now if you take a look at here, this term exactly equal to this term, x sub n. So I have x sub n is strictly superior than 2 x sub n minus 1. Okay, so this one equivalent to x sub n minus 1 is strictly inferior than x sub n. Okay, so this equivalent, I'm going to divide both sides by x sub n minus 1. Okay, so we'll have 2 is strictly inferior than x sub n over x sub n minus 1. This one equal to y sub n is multiplied by x sub n. So now I have proven this one as you see it. In the same time, this one is strictly inferior than this term which we have before, which is strictly inferior than 3. Okay, so now thus 2 is strictly inferior than x sub n is multiplied by y sub n is strictly inferior than 3. Okay, for all n integer strictly superior than 1. Okay, now I have proven this one. Thank you for watching. Just consider subscribe. If you have any question or comment, just put it in the comment section below. Thank you for watching. I will see you in the next video. Bye.